All right, welcome everyone. Good evening or perhaps good early morning, depending on where you are joining us from. My name is Zach and I'm an admissions counselor with the University of Rochester. In addition, I am the liaison between our undergraduate admissions office and our Hagem School of Engineering and Applied Sciences. I'll be in the background along with my colleague Patrick, answering any questions you may have that are related a little bit more towards the admission side. But you will receive a wonderful presentation as well as have all of your questions specifically answered about our biomedical engineering department here in just a moment. I'm gonna pass it over to Professor Amy Lerner, who is going to get things started. But again, welcome and congratulations. And I hope that everything that you are expecting to have answered this evening, you are able to do so. Professor Lerner.
Great, thank you very much, Zach. I appreciate the introduction. And welcome, everyone. I hope you are doing well wherever you are across the world. And I'm glad you were able to join us today to hear a little bit more about biomedical engineering here at the University of Rochester. I would like to take tonight to tell you a little bit more about what biomedical engineering is, tell you a little bit about the curriculum and some of the special opportunities that you have. And as Zach said, I'm really looking forward to trying to answer some of your questions. With me tonight, I have two students who I will introduce in a minute. And they are going to tell you a little bit more about their own experiences here at Rochester and fill you in on some of the extra things that they get to do as part of our program. So I'd like to start by kind of introducing myself. So I am a professor in biomedical engineering and am the chair of our undergraduate curriculum committee. I am also someone who teaches a lot of our design courses and biomechanics and so forth. But I like to share a little bit about my background because when I was in your place, when I was a senior in high school or starting off on my college journey, I didn't know what biomedical engineering was. I actually asked a lot of people about engineering and I wasn't convinced it was quite right for me. And so I started off in apparel design and textile science. And along the way, learned a little bit more about things like engineering and started my first job as a soft goods design engineer, designing parts of the shuttle spacesuit. And so that picture on the right is a picture of me. I actually got to try the suit. I never got to try it in space, but I did get to learn a little bit more about what biomechanics was. And I discovered that there was a career where you could learn about how the hand works. And to design a better glove, you really need to understand how the biomechanics of the hand or the body works and so forth. And so I decided to go back to school and study biomedical engineering. And with a focus on biomechanics and computational biomechanics in particular. And that background has really led to a lot of the different things that I do here at the university in terms of design, in terms of developing new medical devices, and in terms of working in developing systems that allow for quality in design. And so actually, why don't I start off by, I'd love it if some of you would tell me a little bit more about what you think biomedical engineering is. And so feel free to jot something in the chat if you want to tell us a little bit more about what you think of when you think of biomedical engineering and what kind of questions you might have. Katie and Natnell will be happy to answer some of those questions, and we'll make sure we can touch on some of those things along the way. I'll also introduce you to some of our faculty. So these are photos of some of our primary faculty in biomedical engineering. We have a nice mix of faculty with all different kinds of research interests. And these are some of the people who will teach some of your courses in biomedical engineering, serve as your faculty advisors, and also provide research opportunities and so forth for you as you consider biomedical engineering yourselves. So what do I now believe that biomedical engineering is? There you go, the intersection between engineering, and that's exactly right. It's a very, very interdisciplinary background or degree. We bring together different kinds of engineering, some of the more traditional disciplines with the biological sciences, and often are trying to solve problems that are medical applications. We might be developing new systems that might be used in the operating room. We might be developing new devices. The little picture, inset picture here is actually a camera that you swallow like a pill, and it can take pictures of the inside of your digestive tract. Or we might use engineering tools to study the basic sciences of how cells interact with other tissues or with each other. Generally, what biomedical engineers do are trying to solve problems, but first they have to define them in the terms of engineering sciences, and then develop solutions that solve both the fundamentals of engineering, but also some of the limitations and requirements that come up in the challenging spaces of the medical field. It could be designing devices, it could be developing brand new tissues, tissue replacements, could be new instrumentation for monitoring or diagnostics of disease. Some of our alumni are working on developing manufacturing processes or developing new methods for developing drugs or vaccines. And again, sometimes they're doing research where they're trying to develop understanding of different diseases. Some typical examples include developing prosthetics. This is a 3D printed prosthetic for a child. It might be monitoring the breathing patterns of a neonate and an infant. It might be developing new nanoparticles for drug delivery, targeted drug delivery to treat cancer or osteoporosis. It might be developing an instrument. This is actually a physician over at the medical center working with one of our students, and he is using an instrument to look down at his vocal cords. So he's passed an optical system through his nose so he can look at his vocal cords while he sings, for example. And so there's lots of different things that you could do with a degree in biomedical engineering. Many of our students do get into industry to design devices or develop new treatments. Some go on to become healthcare professionals, the physician or the nursing staff or the physical therapists and so forth. Some go on for research or teaching or patent lawyers. We have a number of students who've gone on to start companies, and there's really lots of other things that you can do. Here's a sort of pie chart that we put together a few years ago to look at what students do after they graduate with a degree from our program. Some of them go on to disciplines in medicine or physical therapy or prosthetics, physician assistants and so forth. Some go on for a graduate degree, either a master's or a PhD. Many go on straight on into industry. But some go on for other kinds of degrees, including law or dentistry or MBA or things like that. So there's quite a nice variety. And here's a scattershot of some of the different companies that students have gone to on the left-hand side. And on the right-hand side are some of the different schools that our students have gone on to, either for graduate study or for medical school or law school or other areas. So there's really lots of different things that you can do. And I'll start briefly by telling you a little bit about some of the core courses in biomedical engineering. And then I'm going to introduce you to our students. So we've developed a series of courses in that every student in biomedical engineering takes, starting right off with Introduction to Biomedical Engineering. Which is a course that's designed to give you a feel for what biomedical engineering is. And then in the sophomore year, all the students take a little bit of biomechanics, a little bit of systems and circuits. In the junior year, everyone takes signal systems and imaging, a course in biomaterials, and a course on biomedical computation and statistics. And then senior year, everyone takes a quantitative physiology and a senior design course. And I'll show you later on some examples of some of the senior design projects that they've done. Our students also specialize in a different concentration area. And I'll tell you a little bit more about those concentration areas. But I think before I do that, I want to make sure you have a chance to meet some of our students. And they'll tell you a little bit about those concentration areas in their descriptions. And so why don't we start with Katie? And so I'm going to stop sharing and pull up some slides that she put together for us. And if you give me just a moment. Oops. There we go. So Katie is a junior this year, and I'm going to turn it over to you to introduce yourself and tell them a little bit about your experience at Rochester.
Sure, absolutely. Thank you, Dr. Lerner, for the introduction. Hello, everyone, and congratulations. My name is Katie, and as Dr. Lerner said, I am a junior, so the class of 2023, and I am concentrating in medical optics here in the BME department. So I don't know if you've heard a lot about our concentrations, but there are 4 options for the concentrations, including biomechanics, signals and systems, cell and tissue engineering, and the final being medical optics. So I spend a lot of time at the Institute of Optics as well as in the BME department. And these are just a couple of pictures of me and my friends. So next slide, please. Sure. So just a little bit about what I do on campus. I am a teaching assistant in the Biomedical Engineering department, and I actually TA for the Intro to the Biomedical Engineering course. It's one of my favorite courses that I've both taken and also TA'd for, because I get to see the excitement of the first years as they sort of start to figure out what they love about the BME, just as I did now almost 4 years ago. I'm a research assistant in the BME department and was awarded the Discover Grant, which is an in-house award given for the summer. I'm an undergraduate writing fellow. As you can see, I'm here at the Writing Center right now. And this is a person that where you can go to for additional tutoring, and help with writing in all disciplines. And then for some more fun things, I am the mentoring chair for the Undergraduate Biomedical Engineering Society. I'm in a cappella on campus, and you can see my a cappella group there in the purple blazers. And I also am in a sorority here on campus. Next slide, please. So in addition to all of those things, I somehow have enough time to do research. And I do research in one of the primary faculty's lab, Dr. Wasil Lee. And it is a cell and tissue research lab, with my focus being mostly on the imaging side. She and I worked together to sort of create a project that both sparked my interest in the medical imaging world and also had that optics focus, so that way I could get both sides of the cell and tissue side as well as the optics side. And so I am studying the effects of cartilage and looking at the rotator cuff joint, as well as and its relation to osteoarthritis. And I'm so excited to be presenting a poster this week at the Undergraduate Research Expo, and you can see me in the lab giving a nice little thumbs up there, and some of my data, as well as one of my best friends in BME at a presentation last week. So if you have any questions at all about what it's like to be a BME, how to balance doing fun things in addition to being a BME, not that BME isn't fun, because it always is fun, and about how to balance research as well, please feel free to type some questions in the chat. And I also put my email on the first slide as well. So I'm happy to answer any questions that you may have as you're making your decision.
Great, thank you very much. And I'm so glad that Katie is studying rotator cuffs injuries. My husband is suffering with a rotator cuff problem right now, so I hope you fix it really quick so you can help him out.
I hope so too.
But at that point, so next up, I'd like to introduce Nathaniel. I can't see you, but and why don't you tell us a little bit about your experience in BME, and what's your concentration, and what are some of the things that you like to do outside of BME?
Thank you, Professor Lerner. Can you hear me?
Yeah.
Good afternoon, everyone. My name is Nathaniel Ayalo. I am a junior in the BME department. I am international student from Ethiopia. My concentration is cell and tissue, which means I can also minor in chemical engineering. And I'm also involved in lab at the medical center. Coincidentally, me and Katie are in the same lab, so I am also doing research at the Lee lab. I am focused more on the mechanobiology, which studies the impact of mechanical loading on cartilage injury. And for extracurricular, I am involved in club soccer, intramural. I'm not good enough to be on the varsity, so I'm just playing on the B division soccer team. I am also a tutor at the Center for Teaching, Center for Excellence at Teaching and Learning, which means I tutor students on calculus mainly because I really liked calculus during freshman year. So I tutor those courses. I'm also in the Student Association government. I'm in the advisory council, which means that me and 10 other people in the council meet every 2 weeks with the Student Association government president and vice president. They would update us about what they do on campus, and they take feedback from us about what's missing from student services and what are the updates needed for students to know. I was also a teaching assistant last semester for biomechanics, which is BME 201 under Dr. McGrath. So you'll be taking that class sophomore year. My plan after undergrad is to join industry. Right now, for this summer, I have internship lined up at a pharmaceutical company. So I hope to learn about different skills at wet lab and dry lab on PCR and Western blot, which are some things you would be introduced to as you get deeper into this this class. And that's my plan for the future. And so those are the things I have. Yeah, so feel free to ask any questions as well.
Great, thank you very much. So I'm always excited to hear about what our students do. And it was, you know, as I got a little more involved in some things across campus, I started listening to all the things that students were doing in this organization, this singing group and student government. And I thought, how on earth do they have time for this? I thought they were just doing my homework. What's going on? But the reality is that our students are super involved in lots of different things. They, you know, sometimes we look at the courses and think about the balance, but our students are athletes. Our students are involved in musical activities and drama and sports and student government and extracurricular and professional societies and so forth. So really lots of great leaders in the biomedical engineering program. And so you have a nice chance to talk to ask a few more questions. So feel free to type things in the chat as we go. I'm going to keep going and fill you in. There was a question in the chat earlier about how many credits for the major. And it's a little tricky to answer that. I mean, every student has to take about 128 credits before they graduate. But there are a number of required courses within the degree that are not BME courses, but they're still required as part of the degree. And then there are some electives as well. And so let me fill you in a little bit more on some of what's involved. We start off with basic math and basic science that includes your calc and differential equations, physics, chemistry, biology, and then at least 2 additional basic sciences. And these can be chosen. These are really science electives that you can choose to tailor your curriculum to be just right for your longer term interests. People often ask about AP, and many of these courses could be replaced by AP credits, but they don't have to be, and many of our students don't do that. But these are some of the requirements that you'd be expected. We do have 4 concentrations, and you heard about 2 of those so far. First, one of them is cell and tissue engineering. The second is biomedical optics. Those are the 2 that we had here tonight. But we also have a signals and systems, biosignals and biosystems track, which is a little more focused on electrical engineering and instrumentation. And then the last one is biomechanics, which has to do a little bit more with physical medical devices, maybe prosthetics or pumps or heart pumps or things like that. So in each of these concentrations, there are 3 courses that are focused in sort of a traditional discipline, and then 1 BME course that applies engineering directly to problems in the medical field, medical applications. To give you a sense of what some of these concentrations mean, rather than focus on what the courses are, I thought I'd tell you a little bit about some of the research that our faculty are doing. And this gives you a feel for some of the opportunities in research that our students get involved in. As you heard, students are often involved in research laboratories, either in the summer or part-time during the academic year, or for independent study credits and so forth. So cell and tissue engineering is looking at the interactions of cells with each other or with other tissues or with other structures, sometimes in implants. Sometimes we're developing drugs. Sometimes we're trying to develop sensors that can identify whether a protein or particle has been trapped. We've even have some research in developing new tissues or developing bandages that can detect whether an infection is present. In medical optics, this can range from things like looking at how vision works, that's all optics, but also using optical systems to investigate what's going on in the body at the cellular level, for example. Also microscopy or lasers that are used in medical devices in medical applications could be of interest as well. In biomechanics, we have an interesting department because some of our faculty are concentrating on things that are very, very, very small, at the nano particle level, and other faculty like me are looking at larger scale things like whole organs. And this is a computational model of a knee joint. And then we have people looking all in between. You heard a little bit about some mechanics of cartilage tissues. There's people looking at blood cells and so forth. So biomechanics can really cover a wide range. In signals and systems research, we have several faculty who are looking at various different aspects of neuroengineering. So whether it's the neural control of movements, or looking at hearing or how we process hearing, there's a number of people looking at that. But also imaging is another area of great interest, whether it's ultrasound imaging or magnetic resonance imaging or other kinds of imaging modalities. And as I said, many, really most of our students get involved in some kind of research. Last time we counted, about 90% of our students do participate in some research project outside of the classes that they're required to take. And still, many of our classes actually involve some kind of research project, whether it's a final project or a report or proposal that students develop. Often there are things or homework that is connected to research that faculty are doing. So there's lots of different ways. There's a variety of summer programs that students can participate in to get more involved in research as well. I mentioned our senior design program, and I'll be looking forward to having these 2 in our senior design class next year. This is a 2-semester sequence where students develop solutions to real-world problems that are presented to us by members of our community, whether they're companies or physicians from the medical center, or just members of the community who have some challenge, maybe a physical disability and they need some adaptation. Our students are presented with the problem, and then they go at trying to develop a solution for that problem in teams. to physically prototype something that might serve as a solution to that problem. And we're right in the exciting part of the semester where, they're really working on the final details of their prototypes, and I'll share a few more examples as we go. But we will be presenting those to the public in a few weeks, so just before exam time. Along the way, students learn about the FDA, how to get a device approved, and also how to file a patent, and some of the other intellectual property or manufacturing issues that might come up. Here are a few more examples. We have a team that used an optical system to develop detection for diabetes, but they were doing it not for people who live here in the United States, but in fact for other settings. In this particular case, they were looking at the South Pacific Islands and some of the challenges that might come up in that kind of setting in detecting diabetes. We had a team that was working on a Braille reader for people who were losing sensation in their fingers. So people who develop diabetes, for example, often lose both their vision and the sensitivity in their fingertips. And so if they had materials that were presented in Braille that they were okay with earlier in life, but have lost that sensitivity, they might need a way to read those documents. And so they developed a system that was able to optically read those documents. We also had a group of students that developed a pot skirt that works with cook stoves that were used in Africa. Actually, we had an alum who started a company to develop and manufacture these cook stoves, and they came to us to make it even better by developing something that's called a pot skirt. And so they worked directly with that company to develop an add-on for their product that they're currently selling. We've also developed a walker for kids who have mobility challenges. And this was something a little bit different from a walker for adults, but it was something that was a little more fun and the right size and easier to use for kids who had this kind of need. All along the way, the students developed not only cool prototypes, but also really good communication skills. They learned how to present their research and how to brainstorm with others and how to work in a team. And that's a really important part of the process as well. Sometimes students are interested in master's degrees. People sometimes are interested in doing a combined bachelor's and master's. And while we don't have a formal program where you automatically get both at one in one combination, it's quite straightforward to do our bachelor's degree and then do a master's degree in one additional year. If you there's two options. One is focused on medical devices, and the second is more just general graduate coursework, and both of those take 1 year. If you want to do more research-based masters, including a thesis, it might take 2 years. But again, these are things that you can apply for during either your junior or senior year. And sometimes if you plan it right, you can start the research or some of the courses early to be more efficient. You might even finish in faster than that 2 years. Lots of students go on, as I mentioned, for medical degrees or nursing degrees or what have you. There is no official pre-med major at the University of Rochester, but BME is actually a popular one to use if you are interested in medical school. As long as you plan your electives carefully, all of the pre-med requirements can be completed within the BME major. So it doesn't require a lot of extra courses here, but some students choose to take a gap year or two to do something else first, whether it's a master's degree or volunteer work or a job in industry. Often students will take a little bit of time off. That spreads things out a little bit, and sometimes they'll postpone doing the MCAT, the admissions test for medical school, and that gives you a little more flexibility. As I said, med school isn't the only thing. We also have students who go on to physician assistants or nursing or orthotics and prosthetics and so forth, and really all different kinds of physicians as well, all different disciplines. So BME can be a great preparation for all those different paths. Another interest we have is students are very interested in study abroad. We've had a little bit of a delay or a challenge with study abroad for the last 2 years, but in previous years, we've had quite a lot of students do this, between 10 and 20%, and we actually encourage more to do it. It's often the sophomore year or the junior year, and it does take planning, but it's definitely possible to do. And here's a map of some of the different places where our students have gone to study abroad. And we look forward to that kind of kicking in again starting next year. There are also some summer programs. So if you don't want to get away from Rochester during the academic year, but you do want to study abroad, it can be possible to fit it in during the summer as well. So that's another possibility. Oops. There are ways to do a minor in biomedical engineering if you decide BME isn't quite for you, but for instance, you want to major in biology, but you want to minor in BME, that's possible to do. If you want to major in another engineering discipline, it's easy to do a minor in BME. And just as these students are doing minors in optical engineering or a minor in chemical engineering, it's possible to do one in BME. It requires the same sort of basic math requirements as well as BME 101, that introductory course, and 2 additional BME courses and 1 additional engineering course, but that can be in other disciplines if you prefer. Whoops, lost me. There we go. There are even clusters. So some of you, if you're still not sure about BME as a major, there are ways to do a cluster in biomedical engineering, and this might be the case for someone who's majoring in another humanities or social science field and want to do a little bit of engineering, a little bit of a taste of biomedical engineering. These are some clusters that might be suitable for you. So typically, a lot of people are just wondering, what is it going to start? What's it going to look like in the beginning? We start with BME 101. This is designed to, as Katie mentioned, to get you started in your, to apply your enthusiasm for BME, to solve some problems, see what engineering is like. And then students typically take some kind of math. It's not always, it varies quite a lot, but between kids, depending on what their high school math was like. And then chemistry is typical, although again, that's a place where AP credits can make a change there. And then they take either a humanities or social science or a writing course. And this is a way to balance out the engineering and science courses. But there's lots of different variations. We also have students who are joining late. They may take alternate courses to substitute for BME, but we really encourage people to start with that if they're pretty serious about BME. If you are a BME major, if you're on the fence between BME and biology, that's okay. That's actually fairly common. You can do bio early to make room for BME 101 later, or you can do BME 101 early and try bio is offered both semesters, and so one of the best ways to do it is to do BME 101 in the fall, see if you like it. There's still room to do biology in the second semester, and so there's lots of ways to balance that, at least for a year if you're not sure. And so with that, I have covered the things I wanted to cover, but I'd be happy to answer any questions, and the students are still here to answer any questions as well. So I'm going to go ahead and stop sharing so that we're here to answer any questions that you might have. And actually, I can share quick one more slide. I didn't realize that was there, with a little bit of contact information here. If you want to reach me, this is our webpage as well. And Taimi Marple is our undergraduate coordinator. She is someone who, if you wanted to reach out, she may be able to help you make an appointment to meet with a faculty member or a student by Zoom if you'd like to chat further in person. But we're happy to answer any questions that you might have. just type them in the chat, or we might even be able to have you raise your hand and ask a question if you rather just shout it out. Anything out there? Katie, did you tell us what you're thinking of doing after you graduate? I can't remember.
I did not, but I can share a little bit about what I hope to be doing.
That's great.
So in my future, I hope to pursue a doctoral degree, so a PhD in BME, with a focus in medical imaging. This summer I get to explore a little bit more of my optics side at an REU, so a research experience for undergrads at UNC Chapel Hill. So I'm very excited to go off to North Carolina this summer.
That sounds great. Great. And Nat, you mentioned a medical or a pharmaceutical company. Where will you be this summer?
Yes, so the company's name is called Vertex Pharmaceutical. It's in San Diego, but I think their headquarters is in Boston. They're known for their cystic fibrosis drugs, and I hope to be working on early stage drug development of a sodium channel inhibitor that they hope that drug candidate to be used for pain relief. So yeah, I got to know this company through Handshake, which is one platform I think students can use, and like something that I think the university offers, which is companies that would recruit students to apply for these internships and jobs for senior students. So that's how I got this role, and I think students will appreciate this platform.
That's great. And so you'll be in San Diego?
Yes.
Oh, very exciting. Great. Yeah, no, I think we have some alums who work there. So that's great to know that they're recruiting. We often have a great alumni network that helps students find positions both in research and in industry. So that's terrific. And Handshake is a great tool for that. So.
And I will say just a little bit about my initial experience. I came into U of R thinking that I was going to be a cell and tissue engineer, and also thinking that I was going to be pre-med. And now I'm here almost 4 years later, thinking loving optics and loving the imaging world. So there's although there may be lots of requirements, there still is a lot of flexibility within the program, and to find something new that you're excited about and you can explore those passions. So just a little tidbit of knowledge, and it's okay to change your mind.
Absolutely. Absolutely. That's great. So I wish I could point out the window and show you what Rochester is like today. It was starting to warm up here, and we're all looking forward to spring. And I think it's been great to see lots of interested students on campus. If you aren't able to make it to campus, do let us know if there's something you'd like to see, and we can share some images or walk you through a laboratory or walk you through a building if you'd like to see some things. So I'd like to thank you all for joining us tonight. If we don't have any more questions, I think maybe we will wrap things up. I hope it was helpful for you. Don't hesitate to reach out. I'm easy to find on the BME web pages. There's lots of information there as well about our faculty, their research, some of the student organizations, and we'd be, again, happy to arrange a conversation either with a student or with a faculty member as you're trying to make this big decision that you've got in the next few weeks. So, Zach, any final words?
No, I mean, first and foremost, I want to thank Professor Lerner and Katie and Nat for volunteering some of their time this evening. And I'd like to thank all of you for joining us. If you do have any questions, like Professor Lerner said, feel free to reach out. And if you'd like to just reach out to me, I'm on the admissions webpage. I can put you in contact with Taimi or various other individuals as well. So we do hope to answer all your questions. We know this is a very difficult decision that you're making over the next few weeks. So please stay in touch if there's anything that we can help you with. But other than that, thank you all, and I hope you have a great rest of your night.